Greetings, salutations, all those nice things. Welcome to the show. We're your hosts, Mr. Athide,
Ms. Thibodeau,
and Mrs. Reason.
What's
Today, we'll be looking at the slope point form of a line. It is one of three ways to represent linear functions that we'll be looking at. It's often used as a stepping stone to get to the other two slightly better versions. But here's how it goes. It's based on this slope formula, except instead of using x1, y1, and x2, y2, that second point could be any general point. That's what we're saying, that any general point is related to this first point based on the slope. So here we go. Normally we'd say y2 minus y1. And on the bottom we'd say x2 minus x1, but that's not x2 and y2 anymore. It's just x and y. There's that business. And for slope point form, we get rid of that denominator. So what I do, nailed it, oh no, is I multiply both sides by that denominator. Boop, boop. There's got to be a faster way to access the colors we use most frequently, you know? On the left side, that means we have no more denominator. Those things just cancel each other out. Which leads us to the final version of this formula, which is in that blue. Which is y minus y1, that's our left side now, equals, and on the right side, we don't expand things, just m times x minus x1. So this is slope point form of a line, where x1, y1 are the point on the line, and m is still the slope. Let's do some examples.
Okay, so we are going to take a peek ski at this guy, and we are going to start by just stating the slope and the given point for each equation. And so we're going to start by picking a color, and I'm feeling this one. Okay, so our slope belongs right before x minus x1, and you can see that over here will be 2. So our slope is going to be 2. Our point, if you notice in our equation that we came up with before, we have minus x1. So our x1 of our point is not going to be this negative 1 because it's minus x1, which means x1 is just that positive 1. And similarly, if you look at the OG equation here, we have minus y1 as well. So in our equation, we have negative 4, so our y1 is going to be a positive 4.
All right. Question B. Okay, so same as what Ms. Thibodeau was saying. We're going to start by taking a look at the slope, which we're going to always find here right in front of the x minus x1 section. And remember, for slope, you're always going to include that sign. So in this case, it will be negative 1 over 2 or negative 1/2. And then the point, again, looking at the y1 and x1 locations, here and here. We're going to find those two values. And so again, because we're saying x minus x1, x minus positive 6 is the same in this equation. So our x value is just positive 6. And similarly, our y value is positive 3. A way that people often think about this is that you look at the sign shown in the equation and it's the opposite. So we had a negative showing up in the equation, we have a positive 6. Or same with 3. So if that's a hint that helps you keep it straight in your mind, that is great.
This sounds super straightforward. Let's keep partying through this thing. I think I will use this color here. Let's see. Based on my knowledge, the slope is... I don't even see a number here. Let us not forget that a negative is like multiplying something by negative 1. So the slope is negative 1. And then the point, we're just kind of sticking those things there. What are we subtracting from x? What are we subtracting from y? Oh my goodness, that's not subtraction at all. This is mayhem. If you want, just for how you picture it, you could rewrite that side. Just so you know what's going on, so you can see what you're actually subtracting. In this case, we're subtracting negative 2. As per the hint you received in the previous question, we've got some opposite signs business going on. So since this is positive inside the brackets, the actual point is relating to a negative 2. And similarly, since it's y minus 1, the y value is positive 1. Boom diada. Anyone else want this?
Ooh, you know I do. All right, looking at this next piece here, we're finding our slope right before that x minus x1. So our slope here is 3/5. And just as Miss Friesen and Mrs. Friesen and Mr. Athide said, we are looking at the opposite sign. We could go ahead and rewrite that if we so desired. So our right-hand side becomes 3/5 times x minus negative 7. So our x is going to be negative 7, or x1, sorry. And our y is going to be negative 5. Alrighty, moving on to this next example.
I'm back. Okay, so let's take a look at a different color here. I like that one. All right, so we are going to look at our slope again, just in front of the x location of our formula. So we have a slope of 2/3, okay? And then our x value for our point is just here again, so we're going to start with the x value. But the y's are looking a little crazy over here. And I just want to remind you that saying y minus 0 is the same thing as saying y. And so in that case, we know that our missing y value from our point is just 0. There we go. Mr. Side?
Wicked cool. I got this. I got this in. I don't know. Brown. Okay, so I got me some slop, which is a half, and then my xy point is, there's nothing being added or subtracted to my x. T-Fries, what did you say we do in that case again?
Can remember then that x minus 0 is the same thing as x.
Oh, so that's same as x minus 0. Okay, so then I guess my x coordinate is 0. And y can just take on a 7. Neat. Man, I really wish we could, like, I don't know, graph or something from this. That would be cool.
If only that was what's on the next page!
What?
Okay, so we are going to take a look at how to graph a line from this slope point first. So first of all, we are going to plot that point that we could figure out from our equation. Then we're going to use the slope to get to the other points, right? Slope is just rise over run. And then we're going to connect the dots like we've all been practicing since elementary school. A couple of things that you want to keep in mind is that we want to make sure our axes are labeled, right? You could see that in our graphs here, they're not. So realistically, they could be anything. But we're going to label them appropriately. And we need to indicate a scale, right? Oftentimes we assume what it's going up by is 1, but it's not okay to just straight up assume, because you know what that means. So we are going to make sure it's all incredibly clear by labeling our scale for each of them as well. All right, let's do this. Zoom in for effect. What color are you feeling today?
Purple.
Whoa. I wasn't asking you, I was asking the class.
Oh.
But purple it is! Okay, so just for funsies in this first line here, let's just indicate our slope again and our point just so that we have it here. But we really don't need to do that for each question. Just because this is our first one, why the heck not? So our x1, y1 point, our x1 is going to be a positive 1, right? That opposite sign. And our y1 is going to be a positive 2. And we're going to go ahead and start graphing that. And remember what we just talked about, we have to label our x and y axes. So here, the horizontal axis will be our x, and our vertical axis will be the y. And we might also want to come up with a scale, right? Because I could see that my point is 1, 2, it's not going to be past the edges of my graph here. I might just want to go up by 1 in either direction. That's kind of too light for me to see. I don't know. How about this? 1, 2, 3, and so on. As long as I indicate 1 or maybe even 2, we could assume that it continues on in either direction. I have to make sure my x-axis and my y-axis both have a scale present. And now we're going to go ahead and graph this. So I'm going to plot my first point. I have 1, 2, so 1, 2 will belong over here. And then I'm going to graph with my slope. My slope is 3/2, which means I am rising up 3 times, and I'm running to the right twice. And I am doing this consistently until I run out of room. And then I'm going to backtrack, because that's the way we do. And we're going to backtrack, and we're going to keep on going. Realistically, you only need to have 2 points in order to connect this here. But I like to continue all along. I'm going to take my ruler and make it all pretty. And draw arrows to the edge of them to make sure that the line will continue, even though the graph doesn't. Did you feel?
I feel.
Definitely feel.
Sweet! All right.
All right. Let's do another one. So again, if you want to start off by labeling your slope and your point, you can feel free, but you aren't required to. I am going to write on the side just for reference, but we eventually will stop doing that at some point, and you don't have to every time either. Okay, slope 2. You can see it here. And our point is -1, oh, that's a little messy. Let's try that again. -1, -3, just reading it off the equation. All right, next steps. Before we even start putting anything on the graph, we have to label what we're talking about. So we're going to put an X label and a Y label on your axes. Worth noting that if you put the Y label over here or the X label over here, that's still fine. But you don't need them in all the places, so let's take those away. Then from there, we're going to put our scale on the graph before we start working on the actual plotting. So like Miss Thibodeau said before, you can plot a minimum of 1 notch on each axis, but more is also fine. Okay, let's go back to red. Then we're going to look at our point that we have on, we've highlighted, over here, and we're going to put that on the graph. So -1, -3 is going to land me over here. And then from there, we're going to use that slope of 2. Reminder that 2 is equal to 2/1. So that's what we're looking at there. Rise 2, run 1. Okay. And we are going to use that to find all the other points. So rise 2, run 1 until we run out of room on the graph. And then we'll backtrack the other direction. Okay. I'm going to take my ruler here. I'm going to draw in that line to connect all those points. Oh boy. Okay, there we go. And arrows, and I'm going to make that a little bit neater up there at the top. Oh no.
Yeah, now you've done it.
Just kidding. Undo. I'll write over top of it. There we go. Looks good. Reminder to always put the arrows on each end of the line to show that your line is continuing in both directions, even though our graph has just run out of space. Okay, Mr. Thide, it's your turn.
Ooh, let us go. This thing-a-ling has a slope and has a point, I guess. It's kind of exciting. Here I am. I'm going to label my axes because I'm a pro. I'm going to label my scale because I just don't want communication errors. I'm not about that life. Where is -3, 4 these days? Like here? And drop 3, run 4. I'm going to drop 3, I'm going to run 4 to get there. I'm going to drop 3, I'm going to run 4 to get there. Drop 3, run 4 to get there. and continuing the pattern in the other direction. Ciao. Just on this note that you saw in the previous two examples that a ruler was used. Maybe you didn't see it, but I mean, that line was hecka straight because those two used a ruler. If you do this question and your line kind of ends up like that, yeah, you can expect to possibly not get all of the marks in the world because that does not look like a linear relation. It looks like maybe a nice hillside or a mountain or something, but it is not an absolutely consistent, constant rate of change. So make sure you actually are using a ruler. Oh man, is this ruler long enough?
Zoom out.
Good point. I was tempted to just zoom in again. Did I do something inconsistent? Why is this not lining up? I'm just blind. I'm fine. How did I miss? Oh, I missed this point. That's what I did wrong. I got this.
Side.
It was a test. Anyone who noticed passed. There we go. Now I'm in business. So I wasn't blind, I just made mistakes. And I moved the ruler as I was doing this. This is really difficult. Holding a steady ruler. I don't have steady hands, that's why I didn't become a surgeon. This looks good.
And for our last example, we got this one. Oh, yeah. And we're going to do it in this bright pink color, because why not? Our slope here is, again, -1/2. Our point, we have an opposite sign in our x, so we have +2, and we have an opposite sign for our y, which is going to be a -2. We are going to go ahead and we are going to label our horizontal and vertical axes. So x typically goes on the horizontal, y typically goes on the vertical. And we're going to also label a scale, right? As long as we go a minimum of 1 in each direction, we good. Oh, just kidding, that's a 2. In each direction, we good, because we assume that the pattern kind of continues. If that's 1, this has to be 2, 3, etc., etc. We are going to go ahead and plot our point that we know. So +2, -2 will be found-ish here. And then we have a negative slope. So we're going down 2 and across, going down 1 and across 2. So down 1, across 2, patterns and such. Boop, 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 dot, dot, dot. There we go. And we are going to take our ruler and connect all them dots. That's pretty beautiful, I'd like to say. And we're going to draw arrows because our line doesn't stop, even though the graph does. And oh, it's so nice. Yeah, I enjoyed that. All right, that concludes our 7.4. Is that what this was? Mm-hmm. Yeah, 7.4. So in the textbook, if you could take a peek at this stuff and give her a go, that would probably set you up for some serious success.
Yeah, makes sense.
Yep, I'm in.
All right. Adios, muchachos!